this. They give us sigma. In 7.2, they don't. And if they don't, we have to do something a little bit different, okay? But again, looking at this thing here, everybody question with the step. I know it's a long, it's a long, dreadful 5-step procedure, but the calculation, as hopefully your calculation, you guys see that is not difficult. And again, the only reason I give you this, like I said, by the end of class today, you probably forget about this 5-step. The reason why I mentioned this to you guys is if on your homework, on your quiz, on your test, they don't ask you for the confidence interval and they only ask you for a margin of error, you should know how to find a margin of error. Or if they ask you what is a standard error, then you should know how to find a standard error. Or if they find a critical value by itself, you should know how to find a critical value by itself. Okay, so everybody see that they might be able, or they might ask you this 3 item by itself. Okay, they won't, some they will ask you find the confidence interval, which is this is the answer they want. They probably don't want to see the step, right? But again, some question they would just say find the margin of error, and again the margin of error is this. Okay, so let's try another one, and then I will see if you guys have question, and I will answer your question or whatever confusion part you have. Okay, so let's take a look at this thing here, which is again same thing go. Let's say that they give you this item. The title is babies. According to the National Health Statistic Report, a sample of 360 1-year-old boys, baby boys in the United States have a mean weight of 25.5. Assume that the population standard deviation is 5.3. So we know that we have a population standard deviation. Everybody see that. And that will be a very key word in 7.2 is we don't know this, okay? So looking at this thing here, first of all, everybody see that they give us, like I mentioned, right? 80% of this class is try to dissect, try to encrypt what data they give you, right? You try to see, decipher what data they give us, right? So do you agree that we have this thing here, which is our mean, which is our sample mean, right? The sample, the 25.5 is the mean of this 360 1-year-old baby boys, which is, do you agree that that is my n, which is again, the 360 1-year-old baby boys, I have 360 of them, right? So looking at this thing here, which is now, everybody see that again, those are the 2 things we need. And now part A, well, we have sigma, right? It's there, so. But again, we have sigma, which is the population standard deviation, right? So those are the 3 items we need to construct a confidence interval. Well, not quite, right? The next one is we need to know how confident we want, right? How big of this interval we want, right? So we want to construct a 95% confident interval for this mean. So to construct this 95% confident interval, we know that we need to have a critical value, right? A critical value, which is 95, is your common critical value, which is everybody see that 95, the critical value that we have, which is again, looking at this thing here, we know that the critical value that we're using is 1.960, right? That my critical value, my confidence level is 95. So I'm using this 1.96 as a critical value. So if I know this thing here, which is now my critical value, if you remember, I need to find my margin of error, which is the margin of error is the standard error multiplied by a critical value, which is again, I just use a lot of decimal place, but again, hopefully the decimal does not confuse you, because one thing is we don't want to round in the process. I know we only need 3 decimal places or 2 decimal places, but we don't want round in the process. So if they need 3 decimal places, you have to give at least 7 decimal places first. Okay. So again, everybody see that this is my critical value, 1.96 times my standard error, which is 0.27933452266. And if I multiply that, I have 0.5474. Okay. And once I have a margin error, what do I do? Well, all I need to do is take the point estimator, the mean, subtract the margin of error, and add the marginal error on the other side. So you have to add on one side and subtract on the other side. And again, this will be my my confident interval. So my confident interval is this, which is, again, if they ask you on your homework, if they ask you to interpret this, you would say, we are 95% confident. We are 95% confident that the population mean for this 1 years old baby boys is between 24.95 and 26.05. Okay, so again, basically, if you interpret, we just say that the population mean will be between these two values. Okay, so first of all, question with this item here, how to construct your confidence interval. Again, critical value times standard error to give you the margin of error. And again, you take the point estimator, subtract the margin of error, point estimator, add the margin of error, and that will give you your confidence interval. Okay, so now B, they ask you this: should this confidence interval be used to estimate the mean weight of all 1 year old baby in the United States? Explain. Should we use this? Should we say that all 1 year old baby mean weight will be between these two numbers? Hopefully you say no. Why no? Because again, what data do we have? The data we have here is just the baby boys, right? We cannot use the baby boys to estimate the baby girl, right? So again, this thing here, the data they give us is we only take out the 1 year old baby boys, right? So again, we cannot use this baby boy to estimate every single 1 year old baby out there, because again, the weight of the baby girl might be different. And this thing here, if you say all baby, you are not randomly select, right? This thing here, you select just the boy. So you cannot use just the boy to estimate every single baby. Okay, so again, that small word, right? All 1 year old, right? So we cannot use to estimate all of them. And based on this confidence interval construct in part A, is it likely that the mean weight of all 1 year old boy is less than 28 pounds? We can see that again, this thing here, the interval is only between 24 and 26. Clearly, this interval is smaller than 28, so we can say yes, right? We are 95% confident, which given this thing here, we are very confident that is less than 28, right? 95% confident, because again, we guesstimate that the mean will be between 24 and 26, but now they give us, well, is that easy to say that is the mean will be less than 28? We can say that it's less than 28, right? We have 2 extra pounds for our confidence, right? So again, looking at this thing here, everybody see that, first of all, question in terms of the calculation, or question of what we're trying to do here.
Mr. Chang, I have a question. When we get the margin of error, that big number equals 0.5474956722, and then we subtract the mean with that number, are we supposed to use the entire 0.54 or just stop at after 9.6?
You could. The thing is, you could use it. I use it here because I want to keep 4 decimal places, because after you subtract this thing here, after you subtract or add, is basically that's where you round up for your answer, your final answer. So it's depend on what your final answer is. Most of the time, your final answer, they probably ask you for 2 or 3 decimal places. So pretty much, this is where after you find your margin error, this is where you probably just take like 4 decimal places, and then you round up your answer, your final answer. Because this thing here, I think the answer is probably just 24.95. I just keep it 4 decimal places just to show you that I want to keep that. But again, the rule of rounding, like before, is if your data have 1 decimal, your final answer should be 1 extra decimal. So again, that's why this thing right here should be just 24.95. But you can add and subtract the long decimal number. It's just that afterward you have to round up to whatever the digit that they wanted. So
Okay.
that's why. Is that clear?
Yes, thank you.
Any other question here? All right. Let's take a look at the next thing. Yes.
Are we going to do a problem just like this, but where we don't use the table? Or will we always use the table?
Yes, if you use your calculator, which is, we will get there. Right now, I want you to practice using the table, because a lot of questions they ask you to find the critical value, which is, again, that's why I go on this route first. Like I say, by the end of today, you say, oh man, Mr. Tran wasting all my time. But again, the reason I do that is to show you that if they ask you for a critical value by itself, you can do it. If they ask you for a margin error by itself, you can do it. So by the end of today, you don't have to use the table.
Okay.
But bear with me here, because the next problem we still have to use the table too.
All right.
All right. So let's take a look at this thing here, which is, again, one thing is, if we go one way, just like in math, right? Just in math, in everything, if we teach you how to add, we have to teach you how to subtract. Multiply, we have to teach you how to divide. So now what if they ask you, well, if I know the margin of error, how big of the sample size do I need to be this confident, to be fit in the confident level that I want it to be, right? So this is basically the backward, which is now, instead of give you the n, they want you to find the n, right? So how do we find the n, which is, again, if you do the backward not order operation, but if you do the algebraic formula and you do in backward of your margin of error equal to your standard error times the critical value, this is what you get. Okay, so basically this is what you have is, if they ask you to find a sample size, necessary to fit the confidence interval that we need, then this is what we need, is we need to take a critical value, which is your z alpha over 2, times the standard deviation, the population standard deviation, divided by the margin of error. Whatever that result is, we have to square them up. Okay, it's just basically whatever your margin of error is, we do the reverse algebraic operation. Okay, so basically this thing here is, and again, ladies and gentlemen, your n here, this is the other routing rule, because the n is the fixed number, not fixed number, but it's the number of item, the number of people, is the discrete data. So again, if you have the answer as a decimal, doesn't matter how big, how small of your decimal is, you have to round up to the next nearest decimal place. If you have 21.7, round up to 22. If you have 18.072, round up to 18. Did I say 17? But anyway, just no matter what the decimal place is, you have to round up. Okay, so let's take a look at this thing here, which is, again, let's say they say that the population have a standard deviation of 17.3. How large a sample must be drawn so that 95% confident interval for the mu with the margin of error equal to 1.4. So looking at this thing here, again, we don't know the n. That's what we're looking for, right? We're looking for the n. We're looking for how large the sample size must be, right? How large this sample size, which is we're looking for the n. So looking at this thing here, what do they give us? Which is, again, do you agree that they give us the margin of error, which is your m is equal to 1.4? We know that we have to find a critical value, which is hopefully by the end of chapter 7, critical value, you probably will remember this three right here, 90, 95, and 98. Those are the common three that they will use a lot. So again, 95%, 1.96, which is, again, that would be your critical value. And now what do we need to do? All we need to do is plug it in our item, which is my critical value is 1.96. My standard deviation is 17.3, and my margin of error is 1.4. Everybody see that the critical value, the standard deviation, and the margin of error. which is, again, those are the 3 items I need. I plug into this formula, and again, I just multiply them out, which is, again, 1.96 times 17.3. I have 33.908. Divide by 1.4. I will get 24.22, and I take that and I square them to give me 586.6. And again, because it's 586.6, I have to go up to the next whole number, which is 587. So again, I need 587 sample, whatever this data is. If this data is a test taker, is a whatever, I need at least 587 item in order for me to be 95% confident to estimate the population mean. But I see that the idea here is just, again, it's just the reverse margin of error, the reverse item we have. Okay, there's no point estimator because we don't care about estimator here. We just care that how big of the sample we should take so that we include this item. Okay, and again, similarly, if for the 98%, which is, again, the only thing different, 98% is instead of using 1.96, I have to use 2.32, which is my critical value. Everything is the same. Everybody agree on that, which is, again, 2.326 times 17.3 to give me 40.2398 divided by 1.4 to give me 28.74. And I square this thing here to give me 826.1. Again, like I say, as long as there's a decimal, we have to go up to the next whole number. It doesn't matter if the decimal is more than 0.5 or less than 0.5. As long as you have 1, we have to go and overly estimate rather than underestimate, right? So looking at this thing here, we will have a bigger sample size, right? Because we want to be more confident, right? Which is, again, 98% confident. We need to have more sample to make sure that we include everything into it. Okay, so looking at this thing here, question with this item here, how do we find the sample versus how we construct the confidence interval? This one here, they don't ask you to construct the confidence interval because we don't have a point estimator. We don't have the mean to estimate. This thing here, they just ask you to how to find the n, how to find the sample size. Question with this A or B, which is, again, hopefully you guys see that it's all plugging into your formula. And like I say, that's the good thing, or the one thing about statistic is everything they ask you have a formula. The bad thing about statistic is everything they ask you have a formula. You have to know which formula to use, right? So question with is A or B, how to find the sample size. All right. If you don't have question now, let's take a look at how can we not using the confidence interval, how can we find this item without using the critical value? Well, ladies and gentlemen, your calculator, your TI, your best friend can do it for you. All that 5 steps, they can do 4 of them for you. Right? The only last step is step 5. You have to interpret yourself. Okay. So looking at this thing here, this is how you use your calculator to calculate the confidence interval. So how do we do this? You need to hit on stat. You hit stat, which is chapter 3. We do that already. We do the edit. We do the calculation. If you hit stat and you scroll all the way to the left, which is the test. If you hit stat and scroll to the left, which is test, and then you scroll down to number 7, they have a Z interval, which is, again, the Z interval. That is when we have a population standard deviation, we will use the Z interval. Everybody see that way? That's where I have, let me show you. Let me, share. Give me 1 second. So again, if you do this thing here, which is, again, if you have this, which is we turn it on, you hit stat, you scroll over to test, and you scroll down to the Z interval. So everybody see the Z interval. Now, this is the most important thing, is make sure that your stat is blinking or highlighted. this thing right here, do not do the data. If you do the data, you tell the calculator you have the data, use the data. So make sure your stat item is blinking. And now everything else is just as is C, right? So once you have that, which is again, what is my population standard deviation? In this case, everybody see that the population standard deviation is 15. What is my X bar, which is in this case, my X bar is 76.30. What is my N, how many item I have, which is in this case, I have 100. And what is my confidence level, which is in this case, my confidence level is 0.98. Everybody see that you need to convert your confidence interval into decimal. Okay, so if you don't convert it, this will be an error, which is again, everybody see where my number come from. My standard deviation, my sample mean, my N, and my confidence interval. So basically your best friend right here, you tell him what you have or her what you have, and then you just calculate, which is again, this is our answer in our previous problem earlier, which is again 72.81 and 79.79, which is again, this is what we have, which is in this case, you don't have to find your critical value, find your standard error, find your margin error. Your calculator using this item here, your calculator do that first 4 item for you. Now, the only thing you have left is you have, again, this was what we have earlier. This is our answer in example 2. This is our answer. The calculator only used 2 decimal places. That's why we have only 81 and 79 on your calculator. Okay. So again, I just want to show you that the calculator, most likely the calculator only give you 2 decimal places. And your homework mostly asks you only 2 decimal places. Okay, I just give you 3 decimal places just to show you that if we do it by hand, we got this answer. Your calculator will give you the same exact answer, just a round up to 2 decimal places. You have to do the interpolation, which is again, we just say we are 98% confident that the population mean is between these 2 values. Question with this one here. Question on how to use your calculator to calculate the confidence interval. So let's try one more, and then we call it a day for today. We will do 7.2 tomorrow. So let's take a look at this thing here, which is, I think this is your typical question that you have on your homework, your quizzes, and your tests, which is they will ask you to construct a 98% confidence interval, and then they will ask you, go around and they ask you to find a sample size, which is to find the N. Okay, so looking at this thing here, let's say what's the story behind this, right? A simple random sample of 100 electronic component product produced by a certain method. The mean lifetime were 125 hours. Assume that the component lifetime are normally distributed with the population standard deviation. As you will see tomorrow, this is the key, ladies and gentlemen, the population standard deviation, which is sigma equal to 20. So everybody see that we have an N, which is 100. We have the mean, which is the point estimator, which is 125, and we have the standard deviation, which is 20. So looking at this thing here, we can use our calculator, which is again, do you agree that I can use my calculator here to calculate everything I needed, which is again, what is the confidence interval they want, which is again, you hit stat, go over to your test, and then you go down to your Z interval. The Z confidence interval, or the Z interval is your Z confidence interval, which is now, what is my sigma, which is my sigma now is 20, right? And what is my X bar? My X bar is 125. What is my N? My N is still 100. And what is the confidence interval they want? The confidence interval they want is the same, 98. Everybody see that that is what we have here, 98% confident, which is if you type it in, you hit calculate, which is again, this is what we have, which is again, the confidence interval is between 120.35 on the left side, the smaller endpoint, and 129.65 on the right hand side. Yeah, your upper boundary. So which is, again, looking at this thing here, that's why I told you guys that by the end of today, you will say, oh, we don't need that critical value, that standard error, and that margin of error. You do need it, because sometimes, like I mentioned, they just ask you to calculate the margin error by itself, or find the critical value by itself. So again, that's why I go over that. I can go straight to this thing here, but again, I just want you to see the process so that you guys can see how to answer if they were to ask you each of them individually. Question here with A, which is, now you say, oh, we can do this, right? Your best friend can help you a lot. Question with A here, in terms of this, again, you can write it both way. You can write that is, I think on homework, I think they ask you to write it this way, which is the left endpoint comma the right endpoint. Again, this thing here just basically show you that the mean, the population mean, is between these two values. That's it. Question with A here, how to find this thing here, or anybody got lost in terms of how to use your calculator? All right. So again, now for B, there's no shortcut. For B, you have to plug into that formula. And to plug into that formula, you need that critical value, ladies and gentlemen. Everybody see that right here. For part B, they actually find the sample size. And to find the sample size, you need that critical value. So that's why I kind of make you find the critical value, because again, we need them for this way here to plug it in, which is 99%. That's your common, this thing right here, 99%, which is 2.576, which is, again, hopefully you guys see or remember that your critical value times your standard deviation divided by the margin of error square, right? So again, looking at this thing here, question in terms of where my number came from. It's cumulative, the final exam. Again, looking at this thing here, everybody see that we have this, my critical value, which is this item, times the standard deviation divided by n, right? Which is, after I do all that, I have to square them, which is, again, this is what we have, which is, again, I multiply and then I divide by 3 to give me 17.73333 square. And again, if I square them, I get 294.9, which is, I need at least 295 component to be 99% confident. Okay, 1%, you need an extra 198. Everybody see that right here. To be 98% confident, you need 100 component. But again, if you want to be 99% confident, which is you will see that the confidence interval is big, but the margin of error is small. And because the margin of error is small, we need to have more sample. Okay, so again, looking at this thing here, question with this item here between part A, using the calculator. This one here, part A, I did not use the 5 steps. I just use your calculator. And then part B, using the formula, which is n equal to critical value times standard deviation divided by margin of error square. Again, that's the only thing we do in chapter 7, ladies and gentlemen, is find a confidence interval, and then find the sample size. So again, question with this item here, question with A or B.